Ion beam machining or IBM. The definition of ion beam is a particle beam consisting of ions. It is a molecular level manufacturing process based on sputtering of phenomenon. In this, the material removal takes place in the form of removal of atom or molecule from the surface of the workpiece. In sputtering off, the hitting ions will knock off atoms from the surface of the material. The energy supplied will be comparatively lower, such that it should just exceed the usual binding energy of the atoms. The high energy of the ions leads to ion implantation, that is, it will be deposited inside the material, and there leads to multiple collisions, and that may damage the contours. The IBM system includes, first there will be a plasma source which generate the ions. We know that the plasma state is the ionized gas in which ions and electrons are present. From then that we have to extract the ions. So the second thing is that the extraction grids are provided for removing the ions from the plasma and accelerating that ion towards the workpiece. And finally, we should have a table. There should have a table for holding the specimen. The main components of ion beam machine is schematically represented here. It consists of an anode and cathode. When a high electric field is applied between this anode and cathode, it ionizes the gas which is provided inside the chamber. So the argon gas gets ionized and argon ions produced. A magnetic field from the field coils is applied between this anode and cathode to make the electrons spiral. The spiraling increases the path length of the electrons, and hence it increases the ionization. The extraction grids are provided to separate the ions or extract the ions from the plasma. These are usually made of 2 or 3 layers. The bottommost layer is known as the extraction grid, and that is at ground potential. The second layer, that is the layer in between the extraction grid and the top layer, is known as the electron suppressor grid, and it is at a negative potential to prevent the escaping electrons from the plasma. So it will repel back the electrons. Also, this is responsible for shaping the beam and also focusing the beam. A third grid is sometimes included, and this will be maintained at anode potential to improve the performance of the system. The produced ion beam is then directed and focused on the substrate or the workpiece, which is kept on the substrate table. Thank you.